So section 9.2 is on adding and subtracting rational expressions. So we learned yesterday that rational expressions are expressions that look like fractions. Okay, they can have polynomials in the numerator, polynomials in the denominator. And we learned how to multiply and divide. We reduced and then multiplied and so on. Okay? Now we're going to learn how to add and subtract, which surprisingly is a little bit harder than multiplying and dividing. Jason, Basil, do you need to move up here? Okay, so if you remember, we're going to start with the basics. Way back to elementary school. 1/3 plus 1/4. Okay? I don't joke here. Some of you have forgotten how to do this. It is okay. We'll hold hands and get through it together. So we have 4/4 times 1/3. That's going to give me a denominator of 12. Yes. So I get 4/12 plus 3/12, which makes 7/12. So my goal is to get a common denominator. So in that case, I had a 3 and a 4, and I had to combine, like I had to use both of them, right? All right, on the next one, so I have 16, 32, and 64. Do I need to multiply by all of those to have 16 times 32 times 64? No. What's my denominator? 64. So I'm looking for what's called my least common multiple, the smallest number that is a multiple of all of them. So I'm going to have, I'm going to multiply by 4/4. I'm going to multiply by 2/2. And the last one is basically 1/1, right? It stays the same. So when I do this, I get 12/64 plus 2/64 plus 5/64, which gives me 19/64. The denominator stays the same as we do the problem. All right, so number 2 is worded a little bit differently, but it means the same thing. It's basically saying if these were denominators, what would their least common denominator need to be? So if it says find the least common multiple for each pair, that's what we're doing. So imagine that these were denominators, 4x squared y cubed and 6x to the 4th y to the 5th, and I wanted to combine them. And it doesn't matter what's on the top. Okay, let's think about just the numbers, 4 and 6. If I just had 4 and 6 on denominators, what would I change both of them to? 12. I'd make them 12. So it's like I'd multiply this first one by 3/3. I'd multiply the second one by 2/2, so I'm at least making 12. So what about the x to the second and the x to the 4th? What's my least common multiple? X to the, not to the 2, x to the 4. It needs to get bigger. Multiples are numbers that are bigger, right? Multiples of 8 are 8, 16, 24, right? It keeps getting bigger and bigger. So I need the bigger one. So I would need to multiply this first one by another x squared to get x to the 4th. Okay, but this other side doesn't need anything. Now if I had y cubed and y to the 5th, what do I need to change them to? No, that would be if they were 3 and 5, just the numbers 3 and 5. If I have y cubed on the bottom and I have 5 y's on the bottom of the other one, if I want them to be the same, I just have to multiply by 2 more y's, right? To get them to be the same. So I would need y to the 5th. So I'm going to need another y squared, and then this one's good. So my entire denominator is going to be 12 x to the 4th, y to the 5th. That's all I need. Does that kind of make sense? So you're saying, what are you missing that the other one has? Okay, so this one, I have x squared minus 2x minus 3. So when I factor it, I'm going to have x minus 3 times x plus 1. And when I factor this other one, I'm going to have x minus 3 times x plus 2. So imagine those as denominators. Okay, one of them has x minus 3 and x plus 1. What is it missing that the other one has? It has the x minus 3. We're good there. It needs the x plus 2, right? Okay, so let's see if that works on the other one. The other one has x minus 3, which we have, and x plus 2, which we have. Well, it's missing the x plus 1, right? Does that make sense? So that would be your least common denominator, your least common multiple. All right, so let's actually put this into action. Let's actually add these rational expressions together. Okay, so we're always going to see if they have common denominators. If they do, we add or subtract. If they don't, we need to get them to have common denominators. So this first one. So I have x minus 3 over x plus 4 plus x minus 2 over x plus 4. They have common denominators, right? They're the same. So we're good on that part. So when I add them, I keep my denominator the same, and I combine the tops. I have x minus 3 plus x minus 2 So I get 2x minus 5 over x plus 4. That's it. Easy enough. Okay, the next one's a little bit different. What's different about the next one that's going to maybe cause me a little bit of problems? Not that it's x squared necessarily, but see how there's a minus in between them? That's where people will mess up. Okay, so if you have one fraction minus another fraction, what I want you to do is put parentheses around the numerator of the top, or of the second fraction. Okay, so then when you combine them, because they have common denominators, right? When you combine them, you're going to have 3x minus 4 minus parentheses 6x plus 1 all over the x squared plus 1. So you get 3x minus 4 minus 6x minus 1 over x squared plus 1. Do you see how if you didn't put parentheses, a lot of people would forget that minus 1 on the end. They would make it plus 1. So we get negative 3x minus 5 over x squared plus 1. Because you're subtracting out this entire numerator, the entire 6x plus 1. So when we put parentheses around it, we're distributing that negative. Okay, so on the next one, I don't have common denominators this time. I need to get common denominators, okay? So when I look at my denominator, I have x squared plus 3x minus 4. It factors into x plus 4 times x minus 1. So when we look at the other fraction, we say, oh, well, this fraction only has an x plus 4. What does it need that the other one has? You see it needs that x minus 1. Okay, so we're going to multiply both the top and the bottom by x minus 1, just like we did with the 1/3 and 1/4. Okay, so that means I have x minus 3 plus, and I'm going to have 2x times x minus 1 all over x plus 4 times x minus 1. So I have x minus 3 plus 2x squared minus 2x all over x plus 4 times x minus 1. Sometimes I get lazy, and on the bottom of the denominator I write like that. I do little like quote marks, like etc., etc., and then at the end I put the denominator. All right, so we're going to combine. So I have 2x squared minus x minus 3 over x plus 4 times x minus 1. And just like with the fractions, when I have 5/10, right, I don't leave my answer like 5/10. If I had 5 over 10, I write it as 1/2, right? So I always want to make sure that it doesn't go down any further. And in this case, it might. Like, I can factor the numerator. The numerator factors into 2x minus 3 times x plus 1. Does that cancel with anything on the denominator, though? 2x minus 3 times x plus 1 all over x plus 4 times x minus 1? No, it doesn't. So we just leave it like that. Okay, you could leave it in that factored form, or you could leave it in the step before. It doesn't matter. I just want to kind of know that you did check to make sure it didn't reduce anymore. Okay, next row. Yes, I realize that I am terrible with my alphabet, apparently. Did you guys notice? I go A, B, C, D, F, E. I do know my alphabet. I don't know what I did. I probably just like tabbed one over or something and continued on. So EF, so we'll do them as EF. All right, so D. So I have 2x squared minus 30 over x squared minus 9 minus x plus 5 over x plus 3. I don't have common denominators. I know that this first denominator factors into x plus 3 times x minus 3. So that means that I need an x minus 3 and an x minus 3 on the second fraction. X minus 3 over x minus 3. Okay, so what I'm going to do is I'm going to FOIL out that numerator of the second. So I really need parentheses around this x plus 5. So I have to FOIL. Okay, so when I do this, I have 2x squared minus 30 minus, and I'm going to put like a bracket or a parenthesis or something to indicate that I'm subtracting out that entire numerator of the second, right? Because the minus is kind of like in between the two fractions. So it's really like plus and then negative of the entire numerator. Okay, so I'm going to FOIL. I have x times x is x squared. X times negative 3 is negative 3x. 5 times x is 5x. So I'm going to have negative 3x plus 5x is plus 2x minus 15. All over x plus 3, x minus 3. So I have 2x squared minus 30 minus x squared minus 2x plus 15. I distribute my negative n. And this is what I was saying. I get kind of lazy sometimes. I just kind of do like little marks. I don't want to write the denominator over and over again. But I always write something so I don't lose it. Okay, so I get x squared minus 2x minus 15 all over x plus 3, x minus 3. Am I done? No. I want to see if it factors anymore and if anything reduces. Just like if I had, 7 over 14 is 1/2. 7 over 21 is 31. Or 7 over 21 is 1/3. All right, so I get x minus 5 and x plus 3. And I have x plus 3 and x minus 3. So I do have things that cancel. The x plus 3's go away. So my final answer is x minus 5 over x minus 3. All right, the new e. Same idea. Okay, I factor my denominator. Okay, when I factor the denominator, it's x minus 4 times x minus 2. So it means that the second fraction is missing an x minus 2. So I'm going to multiply by x minus 2 over itself. Like multiplying by 1, it doesn't change the fraction. That's why we do that. All right, so I get x squared minus 4 minus, so I'm going to write this all in a bracket. I guess I could have FOILed it out there too. So I'm going to have x squared minus 4 minus, and when I FOIL, I get x squared minus x minus 2 all over the same denominator. So I have x squared minus 4 minus x squared plus x plus 2. I switch all the signs. So I have x squared minus x squared. That goes away. So I'm going to have an x. And then I have negative 4 plus 2. Negative 4 plus 2 is negative 2, or minus 2. All over x minus 2, x minus 4. Okay, this is another one where it reduces out. Reduce, reduce. Do I just get x minus 4? No. Don't forget it's on the denominator. Your final answer is 1 over x minus 4. And I like to put things like that on the test a lot, because a lot of people just write x minus 4. This is where, remember, you write, Mrs. Cox says she puts this on the test a lot. Yeah, you're clearly writing. All right, next one, so letter F. So this one's a pretty complicated one. It looks like it's easy, but it's really not. Okay, imagine, I don't know, what if x was 7? That means my denominators would be 8, 7, and 15. If I had denominators that were 8, 7, and 15, their least common denominator would be 8 times 7 times 15. You see it? So if you have 8x and x plus 8, what do we need for my least common denominator? 8x times x plus 8. I need all of them. I need 8 times x plus 8. I need all three. Okay, so it's going to look a little messy. It's not this hard on your homework, I promise. I'm going to have to write kind of tiny. So I'm going to have, for the first one, if I have x minus 8 over, or x minus 1 over 8, I'm going to multiply by x and x plus 8. So I'm going to have x minus 1 times x plus 8 all over 8 times x plus 8. The next one, I'm going to have 2. It's over an x, so I'm going to need an 8 and an x plus 8. So 2 times 8 times x plus 8. So 8x times x plus 8. And the last one is a 1 over x plus 8. So it's going to need an x and an 8. So 1 times 8x over 8x times x plus 8. And we'll start combining. I'm going to FOIL the 2 here, like the x minus 1 and the x plus 8. I'm just going to imagine that x is out front. So I'm going to have x, and when I FOIL, I'm going to get x squared plus 8 minus 1x, so plus 7x minus 8. Plus, now I have 16, right? 2 times 8 is 16. And I'm going to multiply it into the x plus 8. So I'm going to have 16x plus 16 times 8, 32, 64, 128. Whenever I multiply by 8, I just keep multiplying by 2. So if I have 16 times 8, I did 16 times 2, 32, times another 2, right? 64, times another 2, 128. Does that make sense? It's a good trick for multiplying by 2s, 4s, 8s, 16s. All right, and then I have plus 8x. That's my numerator. My denominator is 8x over x plus 8. A little bit messy, sorry. I tried. So I'm going to get x cubed plus 7x squared minus 8x plus 16x plus 128 plus 8x. All over same denominator. And a couple of these things will go away. The negative 8x and the positive 8x go away. That's it. So I get x cubed plus 7x squared plus 16x plus 128 all over 8x times x plus 8. That's your answer. Now, really, you should see if it reduces. Okay, so if I was really going to see if this reduces, I first look at the 8. Does anything reduce out with 8 or 2 or anything like that? No, because the numerator is 1, 7, 16, 128. Like there's no 2 or anything that's in common, or 8 or... Okay, what about the x? I can't divide by x either, right? Because the numerator has a plus 128. So I can't do that. And then the x plus 8, that's the hard part. In order to see if this reduced out by x plus 8, what you would really do is you would need to do the synthetic division. If it comes out with a remainder of 0, that means that this factored into x plus 8 times something else, and you reduce it down. I don't believe it does, so we'll leave it. So that's our answer. I know, you really wanted to do that synthetic division. I robbed you of that. I'm sorry. Okay, so that's 8.2. We'll play a game.